Okay, Kim Gang, we've got a quick lesson on averages here to try to get an idea how we can picture atomic mass by looking at samples of matter. I'm starting with an example of grades, though, because I think you can relate to grades better than atomic mass. And so I have a list of grades that a student might get, and at the bottom I've given the average. So the important thing is that the average must always be somewhere in between the high and low of the grades. So if the grades are between 90 and 100, the average will always be between 90 and 100. However, it's not always going to be right in the middle. So in example 3, it's right in the middle because you have an even mix of hundreds and 90s. All right? So you would expect your average to be somewhere in the middle in between, which is 95. But in this example, you have a lot more hundreds than 90s, and that drags the average much closer to 100 than the middle. So here the average is 99. And then we can go the other way. In this list of grades, there are many more 90s than 100s. So that drags the average very close to 90, and you see the average is 91. So it's going to work the same way for atoms, except we're averaging the different isotopes, and we're averaging atomic masses, okay, not grades. So let's take a look at that. So here's a simulation that we've used before, and this allows me to make up mixes of different isotopes. So first I'm going to do hydrogen here. And you see that if I make this 100% the isotope hydrogen 1, the mass of hydrogen 1 is very close to 1 AMU. Remember, it's not exact, but that's the mass of hydrogen 1. And if I make my sample all hydrogen 2, the mass is very close to 2 AMU. However, if I make a mixture, it's going to be somewhere in between. So first let me make a mixture, which is 50-50. Okay. And if you look at the pie chart here, this says that you've got even amounts of the two isotopes. And in that case, the average is right in the middle. So it's about 1.5 AMU. However, if we stagger the mix so that it favors one or the other, it's going to move the average towards one side or another. So if I take away some of the hydrogen 1, I now have more hydrogen 2 than hydrogen 1. You can see that on the pie chart here, and you can see the average is closer to that of hydrogen 2. I can also go the other way, where there's more hydrogen 1 than hydrogen 2. And again, you can see that on the pie chart here. And so now the average is not exactly in the middle, but a little bit closer to hydrogen 1. Right? And the more unequal the amounts are, the closer it's going to go to one side. So by taking away hydrogen 2, you can see the average, or sorry, the percentage of hydrogen 1 keeps increasing, and the average keeps sneaking closer and closer to 1 AMU. All right, so I can do that for a while. And again, closer and closer to 1 AMU as hydrogen 1 becomes a greater and greater percent. Okay, and then we can go the other way as well, okay, by getting rid of the hydrogen 1 or having only a little bit, okay, and then increasing the amount of hydrogen 2. And as the percent of hydrogen 2 increases, okay, the average gets closer and closer to 2 AMU. Okay. One more example, I can pick sulfur because sulfur is an interesting element because there are 4 different isotopes. And I'm going to make sulfur 1, okay, or sorry, sulfur 32, the most abundant, and you see the mass of this isotope is very close to 32 AMU, so that's about the average. And what I'm going to do is I'm going to add 3 of each of the other isotopes and just watch the numbers here. So if I had 3 sulfur 33s, it's still mostly 32, but you see the average goes up to 32.00. I'm going to take those away. Okay, now I'm going to add 3 sulfur 34s. And now the average is 32.03. It's still really close to 32, but it's a little higher than it was before. And that's because sulfur 34 drags the average away from 32 more than 33 did. Okay? And if I take those away and add 36, 36 is an even higher number. It's going to drag the average even more. Whoops, I just want 3. So now it's 32.08 instead of 32.00 or 32.03. So the bigger the difference from the original value, the more of an effect it's going to have on the average. All right, hope this helps. See you guys later.